In 1985, Peter Nauer offered a profound insight in his paper, Programming as Theory Building. For him, programming wasn't just about typing lines of code, it was the process of constructing a living theory within the mind of the engineer. When developers build systems manually, they hold a deep understanding of every component and workflow. But as AI enters the development lifecycle, this cognitive link is at risk of fracturing. When AI handles most of the coding, the theory no longer resides in the engineer's mind, turning source code into a black box. Beyond technical debt, the tangible code that needs optimization, the industry is witnessing the rise of comprehension debt. This is the decline in a team's understanding of their own system, decreasing in inverse proportion to the volume of AI generated code. A study by Anthropic in early 2026 revealed that engineers who rely too heavily on AI scored 17% lower on system logic comprehension than those who develop manually. This creates an illusion of competence, leading to a loss of control over core architecture and making debugging nearly impossible when systems inevitably fail. To solve this, the history of AI integration in software engineering has evolved through several pivotal eras. Chapter 2: The Evolutionary Path. Let's trace the journey from basic prompts to complex automated systems. Between 2022 and 2024, prompt engineering dominated. The focus was on manually refining instructions to guide language models. However, this required constant human intervention and typically only solved isolated, short term problems. Prompt engineering had significant limitations. Systems were largely stateless, meaning the AI couldn't retain context between sessions. It couldn't learn from past interactions, and often repeated the same mistakes. By 2025, context engineering became the industry standard. Powered by RAG, it provided AI with real world data, allowing it to generate code that actually respected the project's specific context. While context engineering improved understanding, it remained reactive. Humans still had to spot the errors, and the AI only fixed things when explicitly asked. This lack of proactivity was a major hurdle for fully autonomous systems. Today, we are entering the era of harness engineering. Instead of trying to make the AI smarter, the focus has shifted to designing an execution environment with architectural constraints and verification loops that allow AI to operate independently and reliably. As Mitchell Hashimoto noted in My AI Adoption Journey, the core of mastering AI isn't about better prompts, it's about building a harness, a robust infrastructure for execution. Chapter 3: Harness Architecture. Exploring the core components that form the execution framework for agents. Modern software development architecture is modeled by the formula agent equals model plus harness. The model acts as the logic engine, while the harness maintains execution principles, routes data, validates output, and manages state. A robust harness consists of three core components. First is the Model Context Protocol, or MCP. This standardizes how AI interacts with file systems and external APIs, ensuring consistency and security. Second is artifact-based state management. Instead of asking the AI to remember a long conversation, the system stores designs and plans as persistent documents, keeping the AI aligned with the overall architecture. Third is the deterministic control plane. This coordination system forces the AI to follow sequential steps, from planning to verification, eliminating impulsive or improvised coding decisions. In short, MCP for connectivity, artifact-based state for persistent memory, and the control plane for structured execution. This harness shifts the burden from prompting to operating a disciplined system. Chapter 4: The OpenAI Case Study. Analyzing how harness engineering works within a large-scale project. The most compelling evidence for this era is a pilot project at OpenAI. A small team of 3 to 7 members set a strict constraint: build a product with 0 lines of manual code. The results were staggering. In 5 months, they managed a million-line system with over 1,500 pull requests, all executed by agents. This experiment proves that when humans stop writing code and start designing operating systems for AI, development speed can increase tenfold. Engineers focus on building feedback loops, allowing agents to reproduce bugs, write code, and verify it in the execution environment. This harness uses a protocol to provide data via progressive disclosure. The AI only receives the exact context needed for the current task, preventing information dilution and supporting precise reasoning at scale. Combined with mechanical verification through high-speed compiler feedback, the AI can automatically detect errors and adjust its output instantly. With the harness handling execution and verification, humans are freed from syntax to focus on architectural taste and vision. At OpenAI, agents even automated the entire flow, from bug reproduction to auto merging after passing all automated checks. Chapter 5 Conclusion. The new role of the engineer in the AI era. Harness engineering marks a turning point in how we structure technical teams. We are shifting from being traditional developers to becoming runtime architects. Returning to Peter Nauer, programming is theory building. In this new era, that theory doesn't just live in isolated lines of code, it lives in the constraints and environments we design for the AI to inhabit. Our core responsibility is now setting boundaries, building feedback systems, and controlling infrastructure. As Mitchell Hashimoto concluded, intelligence is in the model, but control is in the harness. What can you apply right now? Start with 3 practical principles. First, separate generation from evaluation. Never let the same agent write and review its own code. Second, build an agent map. Use files like agents.md to define clear roles and limits for every AI. And finally, prune your tools. Disable any permissions the AI doesn't strictly need to create a focused and secure execution environment for your autonomous systems. Of course, big questions remain for the future of engineering. Is the harness a temporary stepping stone or a permanent destination for all software development? That will depend on the unique complexity of the systems we build together. This shift is promising, but it demands a total rethink of our resources and architectural limits. What do you think about this new era? Is a strict harness necessary for your projects, or is AI flexibility still the priority? Let me know your thoughts in the comments below, and let's discuss the future of development.